Okay, so I'm going to show you guys how to use Excel to help us solve that problem that we had done in class with the truss two elements. Okay, so if this is your first time using Excel, I'm hoping you guys can follow along. I'm going to try to go through the basics first and then get to the more advanced matrix algebra and analysis later. But basically all that I have here is a blank sheet. I've just copy and pasted two of the pictures I had from my notes earlier today into Excel. If you guys want to do this, all you have to do is click Control C or Command C if you have a Mac, and then paste. And you can paste directly into an Excel document. I like to have these here for reference when I'm kind of building my tables, okay? So the first thing I'm going to do, each one of these little boxes is called a cell. So I'm going to go to cell A1, A for the column and 1 for the row. Let me zoom in here. I'm going to go to cell A1 here, and I'm going to start building a table of all of my nodes and elements. So here I'm going to write element number, basically like which element, node number. I can write degrees of freedom. I'm just typing. And as you can see, this is kind of extending past the cell. So what I'm going to do is I'm going to click on that cell and I'm going to go to this button that says wrap text, and I'm going to do that. Okay. Degrees of freedom now, and then I probably want to know the length of each member, and I also would like to know, let's see, what else do I want to know? Maybe my delta x. Let's insert a symbol here. I'm going to type in delta in the search bar. My little delta comes up, double click, delta x. I don't want to have to do that again, so I'm going to Control C or Command C. I'm using Mac. Command V or Control, and go ahead and put delta Y. And I can now have my sine and my cosine of the element all in here. Okay. So element, I have one element, two elements. Nodes for that element. So I'll probably add a column. If I want to add a column, I'm just going to pull this and shift it over. I'll probably say start node, end node, and then end node. This didn't get bolded or centered, so I'm going to come here, center it, bold it, okay? And I want to make this look like a nice, neat table, so I'm going to highlight all of that, go to this little box or button here, and I'm going to put a bottom double border there to make this look more like a nice table, okay? Now, my start node for element 1, I've already labeled that right here, actually, in my analytical model. So my start node for element 1 is going to be 1. My end node is going to be 2. My degrees of freedom are going to be U1, U2, U3, U4. The length of this is 120, and I want to make sure I know that this is in inches. My change in x, again, is 120. My change in y is 0. And now my sine is going to just be equal to, so this is, let me take a step back. This is the first time I'm going to input an equation into Excel. So if this is the first time for you guys, pay attention. Click the equal button on your keyboard, and the sine function is going to be equal to delta y over L. So take your cursor and click delta y. And you see that this cell gets highlighted. I'm going to use the forward slash to say divided by, and then I'm going to click on L, the length here, and click enter. You should get 0. I'm going to do that one more time pretty slowly. Equals to, cosine now is delta x, divided by L. And you can see the equation is also populating here, f of x, function of x. So then push enter. Okay. For number 2, my start node is 2, my end node is 3. My degrees of freedom for that are U3, U4, U5, U6. My length of that member, I need to now use Pythagorean theorem for this guy. So I'm going to say this is another equation I'm going to input. So equal to square root function SQRT, that's a built-in function of Excel, open parenthesis. It's prompting me to put in the number, so I'm going to put another parenthesis and say that's equal to negative 120 to the 2 squared, right? And then plus negative 60 to the 2, enter, and I get the 134.164, which is what we calculated in class but it's just showing a couple more decimals here because it's more accurate. Okay, now my delta x for this guy, I'm going to have to travel negative 120. Sorry, negative 120. And then the delta y, I'm going to have to travel down 60. My sine, again, is equal to delta y over L. My cosine is equal to delta x over L. And I have everything I need for building some of my matrices now, right? Okay, so the first matrix I'm going to do is for element 1. So I'm going to come here, element 1. Make this look a little nicer. I'll probably highlight this so that I can keep nice track of what's going on. Okay, so, another thing I need to add here, areas and E values. So I'm going to actually go ahead, let me see where I want to add this, probably after or before length. So I'm going to come here, highlight this, and click insert. And I'm going to put an area in inches squared. And I'm going to highlight again, right click, insert, and I'm going to put E value in KSI. Area for element 1 was 1 inch squared. Area for element 2 was 2 inches squared. And then we have 29,000 for both of these. Okay, I think that looks a little bit better now. Now we can go to element 1. And what we can do now is we can build our local K matrix. So K1 prime, okay? Now that's going to be equal to, so you'll have to get the equation for this, right? But it's going to be equal to AE over L, so I'm going to say equals, and then I'm going to find A for element 1 times E for element 1 divided by L for element 1, and I get that 241.67. Next value is 0. Next one is equal to negative AE over L, which is negative of that. And then this one is just 0, and I have zeros here. I don't want to have to put in those zeros a bunch of times. I'm going to click on the cell and just pull it. Now I'm going to say that this is equal to the negative of this. The next cell is just 0. This is equal to this. Next is 0. And then I'm just going to copy Control C and Control V. And I have now my full K matrix. Something that I like to do here to make it known that this is a matrix is just add a side border so I know that this is where my matrix is all at, okay? Okay, let's do our beta matrix now. So I can either type a B or you can do this the correct way and find the beta. Ooh, okay, there we go. Beta 1. Now, that's just going to be equal to our sine and cosine values from here, right? So we're going to have a cosine up here, and then we're going to input the rest of these. Actually, it's probably a better idea to program. Sorry, let me redo these so that we don't have to keep doing this over and over for each element. So let's go ahead and pull up our beta function. Our beta matrix. I'm pulling it on my end. Okay, so our beta, where's my beta? Here we go. Okay, our beta here should be equal to cosine, this guy. This one should be equal to sine. I know we can put in these numbers, but trust me, this is easier because then if we want to edit this, it just gets really straightforward instead of having to redo those. These are always 0. This here is equal to negative of sine. This one here is equal to cosine. This one here is 0 and 0. This one here is 0, 0, and then this one is equal to negative sine. This is all for element 1, and then this one is equal to cosine. I'm going to do the same thing I did for the K matrix and go ahead and add those borders in. And now I have my beta 1. Okay, next step in this process, now I want to get my K1 matrix. So not my K1 prime, I want to get my K1. So now what I need to do, I can either multiply my beta E or beta transpose times K times beta, or I can just plug it into the KE matrix. Now, The reason I'm going to do this the long way is because I want to show you how to perform matrix algebra using Excel. So the first step is I need to get beta transpose. I'm going to make this a T up here just so we know, or a T here because I know the transpose. Now, pay close attention if this is your first time doing, oh, I'm missing a row here. Whoops, let me add this last row. 0, 0, no, this is the last row. This should be here. I'm missing this guy, which is 0, 0, negative C, and then, no, not negative C. What am I doing? C, and then S. Right? Let me make sure I did everything else right. Negative S. Okay, we're good. Now let me fix my borders here. Okay. So you guys can catch yourselves by recognizing these need to be 4x4s. That was a 3x3. Okay. Now, beta 1 transpose. To get the transpose of any matrix using Excel, take your cursor and highlight the amount of rows and columns that need to be populated. So the transpose of a 4x4 matrix is a 4x4 matrix. If you don't have it highlighted, it won't work. Now, type in your cell equal to M. I'm going to just transpose. There we go. Open parenthesis, and it's telling me choose the array. I'm going to choose beta because I want the transpose. Close the parenthesis, and now with all 3 of these buttons clicked at the same time, I'm going to hold on Control, hold on Shift, hold on Enter. So you first click Control, do not unclick it, then click on Shift, don't unclick it, and then click Enter. So I'm going to write here what I did. Control plus Shift plus Enter. This is on a Mac. It's the same for Windows. And I've just populated my transpose. Okay. Pretty nice. I have everything I need now to get K. So what I'm going to do first, though, because Excel has to do one at a time. So I know my K is equal to beta transpose K beta. So the first thing I'm going to do first is multiply beta transpose times K1 prime. So I need to pre-select the 4 equal to MMULT for matrix multiplication. Now select the first array. The first array is beta 1 transpose. Not all of that, just this. Now comma for the next array you want to multiply by, and I'm going to click this one for K1, close parenthesis, Control, Shift, Enter. Now I can get my K1 element. I'm going to do the same thing, 4x4 equal to MMULT of this guy, beta 1 transpose K1 prime, comma, beta element, close parenthesis, Control, Shift, Enter. And that's what we got from class. Now I'm going to come here and I'm actually going to highlight this guy because I want to make sure, or let me see if I want to highlight it or pull it. I'll highlight it in another color. Let's do this green color. Okay, this is just the work I had to do to get to this point, right? Now let's do the same thing for element 2. So what I'm going to do here, I'm going to go ahead and I'm going to Control C or Command C, Command V, and instead of redoing all this, I'm just going to change what's happening here. It's prompting me that this stuff is wrong because it's now selecting it for different cells. I need to edit this. So my K1 element here needs to actually be, I can actually just move these up. A, E over L. Now it works, and the whole thing is fixed with one click of that because I already programmed it to do so with the first one. Pretty cool. Okay, now I need to fix beta. Where is beta? It's this cell down here where it really should be. That one. this one. Okay, and then this guy here should be the sign for element 2. And I'm going to click enter. I'm just going to go through this and fix all of those. I know these two need to be fixed as well. Just kind of drag them up. Okay. All right, so now we have our beta 1, and look, we don't have to redo everything, or anything actually, because it's already done for us. So just by fixing our beta 1 and our K, we already have our K1, okay? Or sorry, this is now our K2. I need to fix all these and make sure we know this is all for element 2. Okay. I'm going to save this right here. All right, so now I have my element matrices done and everything looks good. I'm going to go through the assembly process now. Bold this, highlight this. Okay, and I need to recognize now, we haven't done this part in class, but I'm going to talk about it here. So our final K matrix, this is our K global for the whole truss. Now, how many degrees of freedom do I have for this truss? I need to go back and count. 1, 2, 3, 4, 5, 6. So my matrix, my global K matrix needs to be a 6 by 6, one for each DOF. So I'm going to do actually this. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And I'm leaving a little space here because I want to put my degree of freedom kind of codes in. So this is for code 1, 2, 3, 4, 5, 6. I want to make these all green. I want to center them. Okay. Now, for 1, 1, that's just going to be equal to, actually, it's probably a good idea to come back up here and put the codes here as well. So I'm going to pull this over, shift it over by 1, and put the codes in here. So 1, 2, 3, 4, 1, 2, 3, 4. And then this one was 3, 4, 5, 6. Okay, just so I know what I'm coding. So now this is equal to 1, 1. Where's 1, 1? Right here, click enter. 2, 1 equals 2, 1. Where's 2, 1? 2, 1 is here. 3, 1 equal to 4, 1 equal to, there's no 4, oh no, there's a 4, 1, 0. 5, 1 is 0, no contribution, no contribution. Next row. 2, 1 has to be now here, whatever 2, 1 is. 2, 1 is 0. 2, 2 equals 2, 2. 3, 3 equals this guy plus the 3, 3 from this one. 4, oh wait, that was 3, 2. That should be 3, 3. Whoops, my bad. 3, 2 is this. 3, 2 is just this one. 3, 2 is 0. Okay. 4, 2. 4, 2 is 0. And we know there's nothing here. Nothing here. Okay, 3, 1. 3, 1. 3, 1 is right here. 3, 2, 3, 2, 3, 3 we already did. 3, 4 needs to be 3, 4 plus 3, 4. 3, 5 needs to be just this 3, 5. And 3, 6, it's right here. 4, 1. Let's see, 4, 1, 0. 4, 2, 0. 4, 3, 0 plus this guy. 4, 4, 0 plus 5. 4, 5 is just this. And 4, 6 is that. 5, 1. Nothing, right? There's no 5, 1. 5, 2, there's nothing. 5, 3. 5, 4. 5, 5. 5, 6. Nothing here. Nothing here. 6, 3. 6, 4. Just kind of copying this row now. 6, 5. Ooh, okay. We now have our global stiffness matrix. Okay, I'm gonna save this. Now, I'm gonna copy this and paste it again because I wanna have 2 of them because I'm gonna cross out some stuff now. So now, what we can do is, we know that some of our degrees of freedom are 0, right? So I'm gonna come up here. We have pins at joint 1 and joint 3. So does everybody agree that U1, U2, U5, and U6 are all 0? U1, U2, U5, U6. All of these have to be 0 displacement. So that means that I get to go to U1, to all degrees of freedom 1, 2, 5, and 6 and cross everything out. This is really fun. So anything with a 1, I'm going to push the control button to highlight multiple. Hold on. 1. Why is it letting me do this? Hold on. 1, 2. Is it command? Oh, command button for me. 5 and 6. What is happening here? Let's see. Hold on. There we go. And I'm going to right click. Let me see if I remember this. Format cells. Where's my font? Let's see. I don't like the way that looks. I'm just going to go like this. I want it to be more defined. I want it to be totally horizontal, and then I want it to be a little thicker. So I'm going to come here and make it red, and then I'm going to make it a little more prominent. Ooh, I like that. Okay. So I'm going to Control C and Control V. Number 2, Control V. Number 5, Control V. Oh, this looks better. Okay, now Control C, Control V. Now I'm going to rotate it and make it a vertical member. Make sure that it's 0. Okay. And do the same thing with row 1, row 2, row 5, row 6. And then I'm going to make sure everything here is centered because the text looks kind of funny. There we go. Okay. So if you guys can see, all we have left is this little matrix here. Okay, so our K, I'm going to call this K relative now. Just like K new, whatever you're going to call it. Okay, this is just considering degrees of freedom 3, 4. Because we kind of crossed everything else out. Okay, this is equal to, wait, did my, uh-oh, my values changed. Whoops, okay, this is a good lesson time. So I copy and pasted the matrix, but do you guys see what happened? The numbers changed because it copy and pasted all of my equations. I need to delete all of those. I'm going to leave that there. I'm going to show you the right way to paste this. Copy, that's fine. When you come to this point here, right click, paste special, values only. Now it's the right values. Now I can copy that and paste it here. Okay. There we go. So now I can solve for my load and displacement vectors. Let me populate my load matrix. I call these R because these are not the full ones. These are just the relative ones after I've crossed everything out. So my load vector here for 3 and 4 only, because that's all I'm going to be multiplying right now, is going to be, let me check. So at 3, do you see at 3? What is the load in 3? What is the load in degree of freedom 3 at node 2? It's 0. I have nothing in the x direction. So here my load vector will be 0. And in 4, degree of freedom 4 goes up. This is 10 going down, so it's going to be a negative 10 here. Okay. I'm going to put my borders here. Okay. Save this guy. All right, so now what I can do is I can calculate my U, my displacement vector, because I know, I'll just put the equation here for you first. That's equal to the KR inverse. Make sure you guys know this. I'll do it after actually. KR inverse times FR. Let me make sure this becomes a superscript. Format cells, and I want that to be superscript. Okay, so that's going to be here. So I need to get the inverse of this. So I'm going to pre-select 4 equal to M inverse of, select all this, close the parenthesis, Control Shift Enter, and let me move this over 1 so I can call this KR. I'm just going to copy it from here. I don't want to have to write it again. There. Okay. Oh, it didn't copy my formatting. Let's fix that. Right. Okay. Now I can say, so one thing we have to remember here, I'm getting the displacement vector. I need to multiply this by this, KR inverse by FR. KR is a 4 by 4 matrix. FR is a 2 by 4. Sorry, 2 by 4. 2 by 1. So, I'm sorry, what am I doing? 2 by 2. Okay, 2 by 2 is KR, 2 by 1 is FR. So a 2 by 2 I can't type or talk. 2 by 2 multiplied by a 2 by 1, I would cross out the middle ones and I would just get a 2 by 1. Remember, you kind of cross out the middle ones, the 2 and the 2 cross out, and you end up getting the 2 and the 1 on the outside. So I need to pre-select a 2 by 1 equal MMULT, matrix multiplication, open parenthesis. The first one has to be KR inverse, comma, second one FR, close parenthesis, Control, Shift, Enter. That is my displacement vector. Now, again, for nodes 3 and 4. Probably want to highlight this. Some like final looking color. Maybe I'll do blue for this. So this is now I'll probably move this down even. This is my displacement for nodes 3 and 4. Okay. Now what we can do is we can form our global element displacement vectors. Okay, so here I'm going to say that U1 is just going to be, now U1 completely, let's see, has to be 1, 2, 3, 4. So for element 1, I need to consider all 4 degrees of freedom. So I'm going to have to say 1, let me just copy from here, 1, 2, 3, 4. And that's going to be 0, 0, because I have no movement there. And then these two, Control C, Control, see I did it again, Control C. No, I want to copy these, Command C, and I need to paste just the values. Okay, now this is my global displacement for U1, or like the total displacement, not just the relative for 3 and 4, but the total displacement. I can do the same thing for U2. I'm just going to copy all these. I don't have to rewrite it, but U2 now is going to be 3, 4, 5, 6. And then I know here I need to put these guys. And I have 0, 0 for that. Okay, so probably want to highlight all this. Okay, these are the displacement vectors for each element. Okay. All right. Now I can also determine that local displacement, which is little delta. Let me see if I can find a little delta in the symbols. Little delta. Okay, so remember little delta for each element is equal to beta for each element times U for each element. Let me do this so we know. Okay, so all I have to do is basically those are already in the right form, so I can already put those here. I basically have to just copy and paste these, same thing, just putting them in the right notation. I already have my betas done. Oh, sorry, actually this one is not. This one I have to multiply by my beta, but this one will be the same. Let me actually do the calculation here for you guys so you can see. Okay, so this will be equal to beta of my elements. Beta 1, where are you? Here we go. Oh no, I forgot the M mult. So MMULT of beta 1, comma, U of my elements. Now I have to start. Here we go. Close, Control, Shift, Enter. It's the same because beta is just the identity matrix. Let me copy what this is here. This is delta 1. This here is delta 2. Okay. All right, now again I'm going to pre-select equal MMULT of, now I'm going to go to beta for element 2, B2, comma, U, close parentheses, Control, Shift, Enter. Whew. Okay, now these are local displacements. So these are, let me make sure we know this is global. These now are local. So we know how to transform between local and global. Okay, now it's probably a good idea to keep those codes there just in case. Okay. Now we can basically find our local forces. So for element 1, we can determine our local forces now by, so local forces, I'll call this P, E. Those are equal to K, E prime times delta. Where can I copy a delta? Delta for each element. Okay, so now my P1, just copy these and put them in there. It's a little bit easier. P1 now, our element forces, these obviously need to be edited. So I'm going to say equal to, actually let me clear them first. Backspace, backspace, this is now P2. Okay, pre-select equal to MMULT of KE prime. I'm just following this equation. KE prime, so K1 prime, comma, delta E, delta 1, Control Shift Enter, and then this one here is equal to multiplication of K2 prime, comma, this here, close, Control Shift Enter. Okay, and you guys can see element 1 is in tension, because I start negative and then positive, so tension. Element 2 is in compression. Okay. Now, last step here, we can get our support reactions. Let me bold this. So you should be pretty quick at switching between the global and local domain and vice versa. Our support reactions, F, the final support reactions, are going to be equal to K times U. Okay, so my F vector, I'm going to be, I'll just use these here. Okay, and here I'm going to come and pre-select all of this, say equal to my global K, where's my big global K, comma, my U, where do I have my U? Oh, I didn't write my whole U out. I'm going to have to do that first. Did I not do that? Okay, undo. I need to write out my whole U. So my complete U is going to be basically 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. I'm just copying and pasting 5, 6, or 0. Okay. Now I can come back here. Equal to MMULT, matrix multiplication. Oh, whoops. I have to pre-select, remember. Equal MMULT of K, big K, where are you? This one. Comma, U, close parentheses, Control Shift Enter. And I get this here. Okay, now this is just because of rounding error, but it's so tiny. Well, all we have to do here to fix this is select this, format cells, number, 2 decimal places. We can even make this 1. And that's going to fix it to 0.0. So remember, these are the external loads applied to the structure. here, and everything else are the reactions in each direction. So I'm going to highlight, bold this, center this, make it all pretty. Okay. And that's pretty much it. Okay. So go ahead and make sure you can recreate this document. I'm going to post this on Titanium for you as well. Okay. But I want you guys to make sure that you can follow along, because for your final, we might have to use Excel, or I might require you to use Excel. So make sure that all of this makes sense. Okay.